and welcome guys. So in this video I am going to make a machine learning model which will predict income based on census data. So in this video I am going to use the dataset from Kaggle. So let's go to the Kaggle. So this is my dataset, adult census income dataset. Okay, in this dataset we have to predict whether the income exceed 50k per year based on census data. Okay, so this is our data set, and first of all we have to download this data set. So let's download this data set from here. Okay, so when you download this data set, it's something like this, and let's open this. So this is the data set adult.csv. This is a very weird data set in which we can't know what is trying to tell. Okay, why this is so? Because there is no label in the dataset, so that we can't recognize what type of data it is, what value it's showing. Okay, so in this video I am going to tell you how we can deal with the dataset having no header, and also I am going to teach you how we can deal with the data, how we can deal with missing data, like as you see here we have a missing data. So if we directly apply our machine learning algorithm, then definitely our machine learning model will definitely predict a bad result, and we will get a bad accuracy. Okay, a very less accuracy. So we have to deal with such type of data, and so we have to deal with this missing data and many more we have to do. Okay, so first of all let's find out what's value this data set is showing. What is this 39, what is this and this? We don't know. So let's go on Kaggle and see whether the information is something is given. Okay, so let's scroll down. So first of all let's go to task, and here our task is to build a model that predict whether a person has income above 50k. Okay, so our task is okay, so this is our target variable. So we have to predict whether the person have income greater than 50k or less than 50k. Okay, if the income is greater than 50k, then we have to predict yes, and if it's not, then we have to predict no, it's below. Okay, something like that we have to predict. Okay, so let's go again on Kaggle. Okay, so this is something given. Okay, so here as you see here, the information about column is given here. Okay, so here 10 of 50 in column. Okay, let's select all and apply, and let's maximize it. Okay, so this is first column representing age. Okay, so here this column, this A column is representing age. Okay, the person age. Great. And what is second one? Second one representing work class. Okay, so second one is representing whether it's state government. Okay, state government or state self-employed, private, federal government, or something like that. Okay, and what is third one? Third one we have to see. Third one is something FN. Okay, so this is FN WGT. This is third one. Okay, and this is education. Okay, fourth column is representing education. Okay, so whether the person is bachelor or high school graduate or 11th or in 9th grade, what is, or is done master, something like that. Okay, and what is this? Okay, so this is education number, how many years of education you have taken, the like this person has studied 10 years, something like that. Okay, and what is next? Martial status. Okay, so this F block representing the martial status, and this is occupation. Okay, so we got it. And this is relationship, whether it's husband or not in family. Okay, so like that here also in this one. Okay, no information given for this. Mismatched. Okay, so let's go ahead. And so this is a work per week. Okay, this is capital loss, and this is native country. Okay, so this is country. This is United States, Cuba, and Mexico. Okay, and last one is this income. Is income less than 50K or greater than 50K? Okay, so overall we understand that this is our target variable, and as we see here that all this are independent variable which will decide, all this feature will decide whether the person should have income greater than 50K or less than 50K, because using this age and this education year and this one, and also sometimes categories also, yeah, and whether the person is male or female, and what is capital loss, what is the number of hour it works, these all will decide. Yeah, number of hour is last 1 2 3. Okay, hour per week. Okay, 1 2 3. So this one is number of hour per week the person work. So these all feature will decide whether the person should have salary income greater than 50K or less than 50K. Okay, so we analyze our data set, and now we are ready to work on this data set, because there are many challenges. First of all, we have to deal with this missing data, so we have to use some tricks, and we have to learn something more to deal with missing data. A lot of data pre-processing we have to do, and also we have to categorize this data, and we have to import this data in a numerical form, because as we all know, as I have already taught you in previous videos, that machine learning algorithm always understand the data in the form of numbers like that. Okay, so we have to do a lot of data pre-processing. So let's get started. So let's use Jupyter notebook. So first of all, create one folder. Let's name it, let's give the name as income prediction, and let's move this one here. Okay, so let's open Jupyter notebook. Okay, so this is Jupyter notebook, and go to desktop, and in this I have to see income prediction. Yeah, this one. So this is income prediction, and this is our CSV file. So let's go here and click here on new and open Python 3 notebook. Okay, so this is our Python 3 notebook. Here we are going to implement everything. So first of all, let's comment out. Yeah, let's give one heading. Yeah, so let's type here importing libraries. First of all, we need some libraries to build our model. So first library is we have to import NumPy. So import NumPy as NP, and second one is import pandas as PD. Okay, so this is our two library. Okay, so if you have not installed this library, then just go to Anaconda. If you are using Anaconda, then just go to that environment in which you are working. So I'm working in Anaconda 3 base environment, so I'm using Anaconda. So open that Anaconda prompt and pip install your NumPy and pandas. So I have already installed, as you see here. Like that, you can also install from here, pip install pandas. You can do these two. Okay, so you can just pip install these two libraries by writing this command, pip install pandas. Okay, so I have already installed, so we are not getting any error. Okay, so next step is to import the data set. Okay, so To import the data set, first of all, let's give heading as importing data set. And the next step is to import the data set. So as you see here, my data set and this my IPYNB file is in the same folder. So we just need to pass the name with this its extension and everything is done. Okay, so to use the data set, let's define one variable data set. From pandas we have to use this command. This is a function of this library. Okay, read underscore CSV is a function to read all CSV file. Okay, and let's pass the location. First parameter is the location. Okay, so here location is adult.csv, simply the name of that file, because my dataset and program is in the same folder, in the same directory. So we have to just pass this name with extension. Okay, so this is the first parameter passed in this read CSV function. But one more parameter you have to pass. Why? Because let's see the data set, then you can analyze. Okay, so data set is here. So this is our data set. So as you see here, the header is missing in this data set. There is no header. So this data set has no header. So we have to tell our program that there is no header. Header is missing. So let's pass the argument header and give its value none. Okay, so header is equal to none, so that the program understand that in this adult.csv file the header is missing. So we have given all the information of for our data set. And what's next? So now next step is to split our data set in independent and independent variable. Okay, so this is our feature. These all are feature. As you see here, these all feature will decide this 50k, whether the income is greater than 50k or less than 50k. So these all feature, this A and the feature from A to N will decide whether the O feature, this 50k will be greater or less. So these all will become our X. Okay, as in machine learning, if you have quite familiarity with algebra, then you know that y is equal to ax1 plus bx2 plus cx3, something like that. This is the equation. Okay, and x1, x2, x3 all are the values which will decide the value of y. Okay, so in that term we can say that y is our dependent variable which depend on the value of x. Okay, so these are our x1, x2, x3, x4, x5, and these all are this x variable. Okay, and this is our y. We can by setting some values of a, b, c, d, that is the coefficient of x1, x2, x3, x4, we will decide the value of y. Okay, so this is our training process, the whole mathematics. This is the whole mathematics behind this machine learning. Okay, so we have to plot some graph, and libraries are doing everything, but we have to understand how it's all happening. Okay, so this is our x1, x2, x3 which will decide x1, x2, x3, x4, x5, x6, x7, x8, x9, x10, 11, 12, 13, 14. These all will decide this y. Okay, so these all will come in the categories of x, and this is our y. Okay, so we have to take a two-dimensional matrix 2D array which will take all this as a x value and this as a y value. Okay, so to do this, let's define one variable as x and let's define one variable as y. So this is our two variable. So what we have to do, we have to write here dataset.ilog. ilog is a function. So in ilog we have to pass the row address and the column which you would like to put in x. Okay, So in this square bracket, we have to pass the location of row and column with comma separated. So here we have to type row and here we have to type column. Okay. So as you know, in Python, if we want to consider all rows, then we are not going to type each number like from 0 to here. Okay. So in Python, it's very easy to do. If we want to take all the rows, then we simply type here colon. This is a part of string slicing. If you have familiarity with Python, then you will definitely understand what this column denotes. If you guys are new in Python, then I would like to tell you that this column denotes that go and take all the rows. Okay, so to consider all the rows in this 2D in this data set, we are using here column. Okay, we have already taken the rows and we can also take all column, but there is one problem. We don't want to take this column because this row and column, this complete value, we are going to put in y. Okay, so we want to take from a to n only. Okay, so to do that, we can use one more thing. You can pass here -1. Why we are passing -1? Because -1 denotes the last location of the data set. -1 always denote the last location of the list. If you have any list and you are typing as index as -1, then it will always take the location as last. But in string slicing, it will discard the last index passed. Okay, suppose if you are going to take any list and you are giving column and the last location, then the data set will discard the last index and take everything. Okay, so by passing this -1, it will discard this O column and it will take from here A to N, but it will not take this one. Okay, so this is very good in Python. So let's type here -1, and to take all values, we have to pass one more function. This is dot values we have to use, so that to extract the values of each index. Okay, so this is done, and same we can use here also. So in this y, what we have to take, in this y we are interested in taking this column and all the rows. Okay, so to take complete rows, we can use here colon to take complete rows, comma separated, and what we have to use. So to extract this last column, as I already tell you, to extract that last column, we can take here -1. Okay, so it will take -1. -1 shows that go and take the last column. Okay, because last denote -1. -1 denote the last. Okay, and to extract its values, let's pass here dot values, and we are done. Okay, so this step is done. So we can check whether we got something or not. So let's print here, print x, and we are getting here the same as here 39, and last one is United States. Whether we are getting United States? Yeah, we are getting here. Okay, so we are getting in the form of list. As you see here, it's a 2-dimensional list, so we are getting here. Okay, and print y, and let's see what's happening. Print y. Oh, so we are getting here 1D list, and as you see here, there is one more logic. Here we are getting 1D list, and here we are getting 2D list. Why it's so? Because slicing always generate a new list. Okay, so if I am going to pass something like that, if I am going to pass here something column, and if I am going to use here like is 0 index 0 1 2 3 4 5 6 7 8 9 10 11 12 13. Okay, and this is 14. So if I am going to type here something like 14, take only 14 and last. Okay, 14. Okay, something like that if we are going to type. So here we are getting this 2-dimensional matrix because we are using here slicing technique. If you are going to simply pass this -1, then it will give you one-dimensional array. This is something the magic. So you can also use this logic to convert your 2D array in 1D array or 1D array in 2D array by using the magic of slicing. Okay, so you can use also this. So this is so we are interested in, right now we are interested in 1D as y. Okay, so let's go to the next step. So what is next step? So we get our x and y, and next step is data pre-processing phase. Okay, why data pre-processing? First of all, let's comment out this, because data pre-processing, why we are going to use data pre-processing, why we are interested in data pre-processing. Let's see here. So we got our the data set. Okay, we are successfully splitted our data set in x and y form, but as you know that, but the main thing is machine learning algorithm always accept the data set in numerical form. So our first task to convert all this in the numerical form, so that machine learning algorithm accept this, because if we are going to pass this character, this string form, then the model will definitely give a bad result and sometimes it shows error. Okay, so we have to categorize this, because as you see here, there is private, there is self-employed, so there is some category, so we have to categorize this. But before that, as you see here, there is some missing data. Okay, so before going on encoding process, first of all we have to deal with this missing data, because our machine learning algorithm will scan all data here, but if we are getting somewhere blank, then it will definitely show, because this blank indicate nan. Okay, in machine learning algorithm will take is it as a nan value, or machine learning algorithm will definitely give a bad result. Okay, accuracy decreases, so we don't want that. So we have to put something here so that it give a good result. Okay, so we have to fill this space. So how you can, so in this project you will also learn this, how you can deal with missing data. Okay, how you can deal with missing data and how, what step you will take to do that. Okay, so to deal with missing data, let's go here. So to deal with missing data, we are going to use Sci-kitLearn. Okay, so let's import this from Sci-kitLearn from sklearn. If you have not installed the Sci-kitLearn, then the same step, go on your prompt, whether it's Anaconda or something different, if you are using Ideal or Spider or something different, if you are using anything, go on your prompt where your Python is installed, go there and just pip install sklearn. Just type pip install and type this sklearn. Okay, so from sklearn we are going to use this impute class. Okay, so from sklearn we are going to use its impute class, and from this impute we are going to use this class simple imputer. From sklearn.impute we are going to import this simple imputer. Okay, so this is the class which will help to deal with missing data. Okay, so we have imported simple imputer. Let's define one object, but because we have to define this class, we have to create an instance of this class. Okay, so let's write here simple imputer. Okay, and first argument what you are going to pass, we have to pass here missing values. So as you in simple imputer we have to tell that take all missing values, and as I already showed you that missing values will of type nan. Okay, let's see here. So this missing value is of type nan. it also have a separate type, like it's a string data type and it's of integer data type. Similarly, this missing values is of nan type. Okay, so we have to pass here np.nan. Okay, so it's a extension of that missing value. It's something, the values of that missing value. Okay, so we have to pass this. And second is what we have to give a one more argument as strategy. What is our strategy? So here there are many strategy, like here we can use something like if the data set is of integer, then we can use strategy of mean, that we provide an instruction to the imputer class that fill that missing value with the mean value of this column. Okay, fill that missing value with the mean value of this column. But as you see here, we have to apply it on every x, that is whether it's string or whether it's numerical. So the good thing is because in string we will never find mean. So for string there is problem if we are going to take mean value. Okay, so for string we can take one parameter of this as most frequent. We can pass strategy as most frequent. What will it do? Let's go on dataset and understand. If I am going to pass here strategy as most frequent, then simple imputer, what will it do? It will fill this nan value with the most frequently occurred value in this column. Okay, suppose let us take one example that private is occurring mostly, many number of times. So this blank space will filled with private. Okay, because it's a most frequent value. It's something like simple imputer will rank the categories on the basis of frequency, and it will fill the blank spaces with that frequency, with that most frequently occurred class. Okay, so here suppose private is occurring mostly, then it will the value will fill with private. Okay, here in this column, suppose sales is occurring many number of times, suppose, let us consider, then this value will fill with sales. Okay, so this most frequent strategy will fill the blank spaces with that column, according to that column the most frequently occurred value in that column. Okay, so according to that the this blank spaces will be filled. Okay, so this is our strategy. So we are providing this simple imputer class that, hey simple imputer, just point out that np.nan data type values which are blank, and put the strategy as most frequent, and simple imputer will go and point out that nan type values and fill with most frequently occurred value in that. Okay, so it's done. And now what we have to do, this is our object, we have not applied yet. Okay, so to apply that we have to use here imputer.fit, and here we have to pass our x and the column. And first of all we are going to pass here x, and in the rows we are going to apply it on each rows. Okay, because we don't know that in which row it's not, and or in which row it's blank. So from which column we can start. So as we see here, in first one we are not getting any blank. Yeah, we are not getting. Yeah, so in first one we are not getting blank. Okay, so let's start from first and let's go to the end. Why? Because in end also sometimes, yeah, in United States we are getting. So when we are applied it, if you want to optimize your program, then I recommend you to check in which column we need or in which column we don't need. because it will unnecessarily takes time to scan each rows and column. Okay, so I have taken it from first column, first index. I have skipped the 0th index. I have taken from first index and going to the last. Okay, so it's done. What's next? So it's applied, and what we have to do, it's only performing, it's only recognizing what we have to put, but it's not putted. Okay, it's not, if we print here print x, then we will get nothing. So to get on x, we have to use here this one again. So it's the imputer is fitted, imputer has scanned everything, and this will reflect the values. Okay, so this step will reflect the values. So on the same one, on the same location, on the same one, from all columns and from all rows, and starting from one column, we are going to use this one, imputer.transform x, and same one we have to pass. Let's go and modify all this. Okay, so this step will modify our x. Okay, so it's all done. Let's run it. It will take some time because it's scanning each rows and column. Yeah, it's done. Yeah, so we have dealt with the data set, missing data set. What's next? We can perform here label encoding. Okay, so next step is to perform label encoding. Okay, so next step is to perform label encoding. So from XGlearn we are going to use pre-processing. From XGlearn.preprocessing we are going to import label encoder. Okay, from XGlearn.preprocessing we are going to use label encoder, and we have to use many things, because if we are going here and see this one, not here, 1, and this 3, this, let's take here 0th index. So first index, 3rd, 4th, 5th one, 6th, 7th, 8th, 9th, 10, 11, 12, 13. So in 13 we have to take. Okay, so 13 encoding we have to perform. Okay, so let's define a separate class for separate object for each. So let's take le1. Okay, next what's 1, 2, 3. Okay, 3, then 4, skip 3, 5, 6, 7, 8, 9. Okay, so like that, le1, then le3, then le4 is not, le5, le6, le7, le8, le9, and I think one is more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, 13th index. Okay, so 13th index we have to use. So 13th. So that's all. That's okay. So we have to pass here label encoder class. We have to define a separate object for each. Why? Because if we are going to pass same object for all, then we are getting in trouble, because separate object will recognize each pattern and it will modify according to that. Okay, so separate categorization is required. Okay, so for here different categorization, from this column different, so separate categorization is needed. Okay, so for this we have to pass a separate, we have to make a separate object for each. Okay, so let's copy paste each. Let's copy paste each. Okay, so it's done. So everything is copy pasted. And one more thing, we have to define one more for y or y. Okay, so this is for y. Okay, because there is one more thing here, y is also there. We have to import this also. So for this we have to define here y. Okay, so y for y, le is defined for labeling y. Okay, so it's done. Now what we have to do, we have to pass x1, this first column, this is all rows and this is first column. Okay, so let's so to do that, let's copy paste it first of all. Okay, so let's modify this. So this is first, this is third index, this is fifth index, sixth, seventh, eighth, ninth. Okay, so ninth is done. Now after ninth there is 13. Okay, so 13 done. Okay, so after so let's define this. So after 13 we have to use this le1 dot fit underscore transform. This will do everything. Here, as you see here in imputer, fit and transform is separate, but here in pre-processing, all class in pre-processing sklearn dot pre-processing fit underscore transform is single function. Okay, so use here, pass the same location, this one. Okay, so same we have to pass in all. Okay, so let's save our time, and here what we have to do, here modify it with 3 and modify it with le3 because this is label le3 object. Okay, so it's done. Let's copy the same and modify the location here le and here le5. Okay, so like that's do for all 5, and this is 6 and this is 6 and this is 7 and this is 7 this is 8, this is 8, le9. Okay, so pass this one, 9, 9, pass here 13 and pass here 13. Okay, so everything is done. 1 3 5 6 7 8 9 and 13, and 1 3 5 6 7 8 9 and 13. Okay, everything is done. Okay, so now what's next? Now y is left, so let's modify to y also. Y dot fit underscore transform, same logic you have to use, transform y. Okay, let's use this. Okay, so it's done. Let's print here, print x. So as you see here, our this state government is changes to this 7. Okay, and United States is changes to 39. Okay, so it's encoded. If I am going to print here y, then we will see some changes in y also. So in y, all values which are less than or equal to 50k is pointed to 0, and the values greater than 50k is 1 actually. Okay, so that's great. So now what is our task? Everything which is 1. So if our model, so we have to tell that if our prediction is close to 1, then it is the income is greater than 50k. If it's 0, it's close to 0, then our prediction is less than 50k. Okay, so that's simple. So what's next? So our encoding is done, all data pre-processing is done. So next step is to to split the data set in training set and test set, because approx 70%, or you can say 80% of data, we are going to use the 80% of this data set to perform on training, and 20% is for testing the result. Okay, so testing and trying to analyze that whether our model is giving a good result or not. So to check the accuracy of our model, we are going to use 20% of data, and to train our data set or to train our model, we are going to use 80% of our data set. Okay, so next step is to split the data set in training set and test set. So let's give the heading as splitting data set into training set and test set. So for splitting the data set, we are going to perform here from XGlearn.model selection class. We are going to use from XGlearn.model selection. We are going to import train underscore test underscore split. From XGlearn.model selection model underscore selection class, we are going to import train test split, and let's define variable because we have to split. So let's define x train, x test, y train, y train, y test. Okay, so let's give here train underscore test underscore split, train test split. This is an object, okay, which will return 4 values: x train, x test, y train, y test. Okay, and what we have to split, we have to split x and y. Okay, and what is the test size? What we want test size? So test size is 0.2. It's 20%. I am giving test set to 20% and 80% to training set. Okay, so remaining 80%, 0.8 is 80% to training set. Okay, and let's give one more parameter, this random state. Yeah, so random state is equal to 0, so that we don't get any irrelevant values. Okay, so this is our train test split. It will take x and y and test size as 0.2, and it will split the data set in training set and test set. Okay, so let's run this. So we successfully split our data set. If we can see from here, x train, yeah, x test, yeah, something like that. You can also see y train, yeah, something, and y test also, y, yeah, because we get. So let's delete this because it's not going to help. Okay, so our splitting part is done. What's next? Next step is to before passing it to our machine learning algorithm, we have to see whether the value is good enough to pass to the ML algorithm or not. So as you see here, we are getting some values like 39, 7, and some values are 77,516. So these are long variation. So here some values are very large, and some values are very low, and some values are in between. Okay, so to solve this problem, we have to scale our values in a limited range, so that our algorithm has no difficulty to analyze and to get some pattern and plot some graph. As I already told you that our machine learning algorithm are going to plot some graph and identify some relation, and so that it identifies the values of A, B, C, D, E, F, all that, so that to give a good result, so that on putting the values x1, x2, x3, x4, we are getting a good value of y. Okay, so we have to fit our graph such that it give a good result. So to fit our graph, we need a good value also. because this irrelevant values, some values are very large and some values are very low, so this will cause a very difficulty, and also our algorithm, machine learning algorithm, will takes time. So to optimize the training process, we have to scale these values. Okay, so to scale this value, we have to use one more step, which is known as feature scaling. Okay, so we can name it as a step, as a feature scaling. We are going to scale the features, we are going to scale these features. Okay, that's why it's named as feature scaling. Okay, so for do feature scaling, we have to use from sklearn dot same pre-processing. All the work, our maximum task is done with the help of pre-processing. So from sklearn dot pre-processing, we have to import standard scalar. So from sklearn dot pre-processing, we are going to import a standard scalar, and let's define one more object for this standard scalar. One object for this standard scalar is this one. So let's define the object, and this is the object sc standard scalar. Okay, so this is the object of this class standard scalar, and what we have to do, we have to, because one more thing I want to tell you here. So here we need only x train and x test. Why? Because x train and x test are only containing these values. Okay, y are containing, all y train and y test are containing this one. Okay, so we need only x train and x test. Okay, so give here x train comma x test. Don't give comma here because we have to separately perform this. So for x train, we are going to perform sc dot fit underscore transform, same as I told you that all pre-processing contain a fit underscore transform feature. Okay, so let's, as you see here, so this is done, and this is sc dot fit underscore transform, and this is x test. Okay, so this is fit underscore transform, so this will fit your this will featured. Okay, this will perform feature scaling on x train and x test, and if you print x train and x test, then you will see the magic. X train, if you print, then you will see the values in decimal. Okay, so the values are great and you will get a good result. So values are scaled to very small values, so that it's easy for the model to plot some graph and identify some relation. Okay, and you, as you see here, they are approximately same, approximately not very large value, and there is no very large variation, so it's best suited for this algorithm. Okay, let's click here, and if you print here x test also, then you will also get same, something like that. Yeah, same. Okay, so it's done. Now we are ready to train our data set. Everything is done. Okay, so as you see here, let's use this one. As you see here, our libraries are imported, data pre-processing are done, we have dealt with missing data, and we also dealt with encoding. We also deal with string data, and we have encoded in numerical form. We got our numerical form, but and we also splitted our data set. Now we perform feature scaling to put our data set in a definite range. Okay, so we are ready for training. So let's write here training data set. Okay, so here we are going to use XGBoost. Okay, we are not going to use here decision tree algorithm or logistic regression, something like that, because I have tested that this model, this data set, and I am getting a very good result in XGBoost. So what is XGBoost? XGBoost is also a machine learning algorithm. Okay, it is also used in for classification and regression analysis. Okay, so I am going to use here XGBoost. So how you can use XGBoost? So you can use here from XGBoost. From XGBoost we have to import XGB. XGB stands for XGBoost and Classifier. This is classifier, and you have to define one variable as classifier is equal to XGB classifier, and you don't need to pass anything. Okay, so this is our XGBoost. Okay, so from XGBoost import XGB classifier. Okay, so this is an algorithm, this is a class which is used to train our data set. Okay, so this is XGBoost. You can also use logistic regression or something other. You can check it on XGLearn API. If you have any issue that how I am blindly accept this, so you can you don't accept, you can first of all you read this API from this Sci-kitLearn API, then accept. So here you will get many things, gradient boosting, something. So here this is decision tree. So you can use this one also, decision tree classifier. So as you see here from sklearn.tree, we can import decision tree classifier, and these are some parameters which, and these are some parameters in decision tree. Using this parameter we can also improve our model performance. You can try this and comment in the comment section. You can tell me that in which model you are getting a good result. First of all, see this XGBoost. Okay, so you can see, you can check out also XGBoost from there. Okay, from XGBoost you can get from like this XGBoost. So this is the documentation of XGBoost. Okay, so something building from getting started with XGBoost. So from import XGBoost, yeah, something you can check this one. Okay, how you can use this XGBoost tree method and something like that, you can check this. Okay, so from XGBoost import XGB classifier. So we have created the object of this class. Okay, so it's done. Now what we have to do, we have to pass our xtrain and ytrain in this XGBoost classifier dot fit. We have to perform, we have to fit our model. So pass here xtrain and pass here ytrain, pass here xtrain and pass here ytrain. So no module found XGBoost, it's showing no module found XGBoost. Okay, so you will also get this issue. So what I am going to do here, pip install XGBoost, same things you have to do. Pip install XGBoost and it's downloading XGBoost. Okay, so like that you can download the XGBoost. So I am downloading this XGBoost here. So XGBoost is downloaded. Okay, so let's run this again. So it's running. So the algorithm has run. Okay, so our XGBoost has run successfully, and we made our model. Okay, so we made our model, but we have to check its accuracy. Okay, how much accurate our model is. So to check our accuracy, I am going to introduce you one more functionality is of confusion matrix. What is this confusion matrix? Confusion matrix, making confusion matrix. So confusion matrix is basically a mathematical, you can say, like a 2x2 matrix, which is used to summarize our model performance. And using confusion matrix, we exactly get how much accurate is our model. Okay, so after so I will show you how accurate is our model, what is the percentage of error in our model, and what is the number of values which our model is predicting correct and which is predicting wrong. Okay, everything I will tell you in this confusion matrix. Okay, so this is the role of confusion matrix, to tell you everything. Okay, so let's build this confusion matrix first of all. So from XGlearn, same XGlearn is going to use everywhere. So from XGlearn.matrix we are going to use. From XGlearn.matrix we have to import confusion matrix. Confusion underscore matrix. And one more class we can use here, accuracy score, because we have to check our model accuracy also. You can also separately write this from here. You can also I will show you one, like from XGlearn.matrix I am importing confusion matrix, and same from XGlearn you can write from XGlearn.matrix import accuracy score, accuracy underscore score. You can use this, or you can simply write it here from XGlearn, just comma separate. Both are same. Okay, both are same. So from XGlearn.matrix I am going to use confusion matrix and accuracy score, these two. Okay, so first of all I am going to use my yPredict. I am going to store my yPredict. So my yPredict, so let's write here yPredict, and this is classifier. Classifier.predict I am going to use. Classifier, this model, this is, what is this classifier? This is classifier, this one. This is object of XGB classifier, and classifier is trained on Xtrain and Ytrain. Now this classifier is actually our model. Okay, so now you can use here classifier and you can change its value to model, so that to get a good, let's change it. You will get it more better way. Let's train it again. Okay, it's train. Now here you will write model. So this is your model. Okay, so this is our model. So this is model. So this is model.predict. So we have already stored this X test for prediction. Okay, so let's write here X underscore test. Okay, so this is X test for our prediction. So on X test we are going to check our model accuracy. Okay, so this yPredict will store the predicted value, each predicted value of X test. Okay, so yPredict will store the predicted value. Now we are going to create the one more confusion matrix object. So confusion matrix, and one more thing, in confusion matrix I am going to pass first argument as y true, which is our true value. So what is our true value? True value is y test, because X test and Y test is left for checking our model accuracy. X train and Y train is consumed here. X test, Y test is left. Y test is that true value of this X test. Okay, so here Y true is a Y test. Okay, and Y true is Y test, and second argument is Y predict we have to pass. So so confusion matrix will take first argument as true value and second argument as predicted value. Okay, and one more thing I want to tell you, that every class which is come in this XGlearn.matrix, whether it's confusion matrix or accuracy score, it will take first argument as y true and second argument as y predict. Every class in this matrix, this XGlearn.matrix, it will take first argument as y true and second argument as y predict, every class. So here you can see, if I am going to print here, print cm, and okay, suppose I am going to use one more thing. I'm going to explain you right now. Accuracy score. So this is also a class of this XGlearn.matrix. So as I told you that every class of this matrix, XGlearn.matrix, will take first argument as y test and second argument as y predict. Okay, so it will also take same. It will also take first argument as y true and second argument as y predict, same like that. Okay, so let's run this first. Let's run this cell. Okay, So you are getting something this, and let's run this accuracy score. So you are getting this 84.75% of accuracy. Okay, so you are getting 84.75% of accuracy. So our model is getting 84.7% of accurate value. And what is this? What is this? It's something like matrix, but we don't know what is this. So I am going to tell you complete about confusion matrix. What is this value? What is this? So this first row represent positive value. Okay, and this second row represent negative value. Okay, so this is positive value, this is negative value. What is this positive and negative? Positive represent that this is 1 is our positive value, that the salary is greater than 50k, and 0 is negative value, that salary is not greater than 50k, that is salary is less than or equal to 50k. So this is negative value, and this is salary greater than 50k, salary not greater than 50k. It means salary lesser equals 50k. Okay, so this is 1 is positive and 0 is negative. Okay, so like that here, this is positive value and this is negative value. Okay, so you can see confusion matrix also. If you search here confusion matrix, then you will see here what is this confusion matrix. You can see this image also, like this is this image. So this image represent that first column, first element of first row represent true positive value, and this is true negative value. Okay, diagonally it is true negative value, and second one is false positive value, and this is false negative value. Okay, so here this is true positive value, and this is true negative value, and this is false positive, this is false negative. Okay, so true positive, what does it mean? True positive means 4528 values are greater than 50k, that is they are 1. Okay, and our model is predicting right. And this 992 is, now out of dataset 992 values are less than 50k, and our model is predicting right. And this 390 represent that 390 model is predicting that 390 values are greater than 50k, but actually this 390 values are less than 50k. So 390 wrong values our model is predicting positive, and 603 wrong value our model is predicting that it's a negative, but it's actually positive. So like that we can use to completely summarize our model accuracy. Okay, so overall you can understand that this diagonal element are actually the main thing. This diagonal element will represent the good value. This diagonal element is good value, and this is the bad false value. This diagonal element are matching with our true value, so these are our only true values. Sum of 4528 and 992 are our true value, and 603 and 390 are our false value, which our model is predicting wrong. Okay, so using this confusion matrix you will get complete idea about your model performance. Okay, so that's all about this. You can also concatenate. Let's using confusion matrix you can see this, and you can also face to face see the result. So for that, let's use some functions of NumPy. So use np.concatenate. So in np.concatenate use yPredict. First I am going to use ypred.reshape. I am going to use why I am going to use, I will tell you. Let's use first of all comma 1, let's give comma y dot reshape length of y comma 1. So I am getting something this. How we are doing this? So we are basically reshaping our y predict. As you see here, our y predict is in the form of 1D array. Okay, so to reshape it in the form of like this 2D array, we can use this function dot reshape length of y predict comma 1 to reshape. Okay, so I am reshaping it in the vertical direction, and also this one represent that axis is equal to 1, and this one is overall concatenation. Okay, if I am going to use here 0, then suppose here I am going to use this. First of all, it will show error because here we also want to take here 0. Because why it's showing error? Because we have set it according to this one. Suppose let's consider let us consider this one representing axis. Okay, so this is our axis of concatenation. Okay, so this step is done to rearrange it in vertical direction, and this step is done to rearrange it in vertical direction, and this one is the value of axis. If the value of axis is 1, then this concatenation of these two array will be vertical concatenation, phase to column concatenation. Okay, but if I am going to use here 0, then let's see what's happening. This is row concatenation. We don't have to use this, we have to use this one. Yeah, so that we compare the y predict with y true value. Okay, so here as we see here, the both are giving same, so our model is predicting correct. Here our model is predicting that it's less than 50k, but it's actually greater than 50k. Okay, so our model is predicting wrong result here. Okay, so if you expand this, then you will get more values. I'm not going to waste my time. So let's do one single prediction and see how it works. Okay, so we have to make a single prediction. So let's comment out with single prediction. Let's take age is equal to 40. Okay, let's randomly take some value. So this is our input value which we have to pass, and we have to do a prediction on this one. So how we can perform this? First of all, let's take one variable result is equal to model dot predict. Same we have to perform here, model dot predict. What we have to do I will tell you later. Okay, because it's I have to explain something more. So model is equal to predict something we have to pass here. Okay, I will tell you later. Okay, so our what our model will return? Our model will return the form of 0 or 1. Okay, so if the result is 0, okay, so our model will return the form of 0 or 1, and our model will return in 1D array. Okay, so if result is 0, like that, if result is this one, like that, 0. Okay, so I want to print a message that person makes below 50k. Person makes below 50k per year. Else, if it's not, that is if the result is 1, if it's not, then result is definitely 1, then what I want, that print same message with above. That person makes above 50k per year. Okay, that's what I want to print. Okay, so we have done everything, but the question is what we have to pass here. Okay, so before passing it, I want to tell you one thing, that this is the data in the form of this one, like that, as you see here. but our model is trained on scale data. As you see here, we have first of all we have scaled the data like this, okay. Then we have passed it to this XGBoost, okay. So first of all we have to scale like this. We don't we are not able to pass something like that, okay. So we need to scale our data, okay. So for scale our data, first of all we have to transform it. So for transform it, we can pass here sc.transform. sc.transform. Why I am not going to pass here fit underscore transform like this? Why? Because fit is already done one time to fit according to this standard scalar. Then I am going to use this same scale to all my new prediction, okay. That's why I am going to pass here only transform. I want that these all new prediction will also scale as same as my model is trained, okay. So that we get a good result, because our model is trained on some scale logic here, standard scalar logic. Some standard scalar logic is used to train our model, and I want that same logic we can use to transform this value also, okay. So that's why I am not going to use here this fit underscore transform, because fit underscore transform will will modify this in some different logic bit. So that's why I'm using transform here, okay. So in transform, what I have to pass, as you see here, everything I am going to, at the time of doing training, model will accept everything in the two-dimensional array. So I have to pass here 2D. But in this, what I have to pass? In this, I have to pass this one, okay, this complete one. So first age 40, so first parameter is 40, same, okay. Now this, what is this? Work class is equal to private. How we identify, how we know the name of this private, okay. So to know the name of this private, let's go to the encoding part here, as you see here. So as you see here, this third one is private, okay. This 38 and private, okay. And here 38, and after that 38, 4 is for private, okay. So as you see here, this, there is also private, there is also private, okay. So here 4 4 for 58 private, 22 private, 58 4, 22 4. So from here, as we see, as we know that 4 is for private, 4 is categorized, encoded for private, okay. So let's pass here 4, okay. And what is next? Employee income. Employee income is 80,000, pass like that, same. This is 80,000, and employee is bachelor. So we have to know about bachelor, whether there is any information about bachelor. No information. So we have to see from our data set where is bachelor. So bachelor is in fourth, 0 1 2 3 4th position. There is bachelor, okay. In fourth position we are getting bachelor. So if I am going to pass here 4 and column, I am going to give 49. What is this? 49,41069. Sorry, this not this. 4 comma column, we have to pass this one, okay, because 4 is row and this is all column. So 28 4 represent this, the fourth one. 28 4 represent this one. 28 4 private, 338, and this one we want bachelor, 0 1 2 3. After 338, this one we want, okay. So for that, so as we see that fourth, this is for bachelor, 9 number is for bachelor, okay. So let's pass here 9. Like that we have to encode, okay. and for employee bachelor is done. Then again 9 is something, some parameter. Okay, and now we want to know about divorced. What is for divorced? So let's go to dataset again. So for divorce, it's third one, it's already given. So for divorce, let's type here third. 0 1 2, yeah, I think 2. 0 1 2, yeah, 2 1. So we have to give here 2, second index. 38 4 2 1 4 5 6 11, something like that, it's given. Yeah, 38 to this is for divorced. Yeah, something given here. 0 1 2 3 4 5, fifth one is given for divorced. 0 1 2 3 4 5, fifth one is given for divorce. This is 0. Okay, so we have to pass here 0. Okay, so fifth one is given to divorced. And what is next? X, executive managerial. Executive managerial is where? I think first one we have to use. Let's use first one. And here we have to see 0 0 1 2 3 4 5 6, sixth one we have to use. Okay, so from 0 1 2 3 4 5 6, so X managerial is 4. Okay, so we are going to use there 4. So like that we have to encode. X managerial is 4. It's done. Now this is husband and white and male. Husband, white, male we have to use. So where is husband, white, male? Here, X managerial, husband, white, male, same. Okay, so X managerial is already there, husband, white, male. So this is X managerial, fourth one is 0 4 1 we have to use. Okay, 0 4 1 we have to use. So let's write here 0 4 1. So husband up to husband, male is done. Now what we have to use? Type here 0, and this one is 1, and this one is capita, this is 1000, and this is hour of working, this is 50. And what is the encoding of United States? I think second one also contain United States. Okay, let's go on second one, see the last one. And in second one, last one is 39. So for United States, it's encoded as 39. Well, 39, it's done. Okay, so if I print this, I'm getting some error. Access 15 feature, but standard expecting 99. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15. Oh, so we are getting one extra feature. 44 80,000 9904 99040 410. Yeah, oh, we are getting here one extra feature. Oh yeah, this one is wrong. So we are getting here 99. Yeah, this 411, and this after 0 we have to use this 1000. Okay, then 50, then 39. Okay, now it's fine. Okay, let's run this. So as you see here, we are getting here person makes below 50k per year. Okay, so we are getting a good result that person make. This is for a new prediction. It's a new prediction. Okay, so I have randomly taken this age. I have randomly prepared this age, work class, and this and all this, and I have got my model as showing that person makes below 50k by identifying all this feature. So as you so now you understand how we can do a single prediction using machine learning algorithm. Okay, so I think for you guys this tutorial will become very long, but I always want to explain you guys a good thing and show you how all this is happening. Okay, not randomly that write this and all this happens. I always try to tell you that what is the logic behind this, how this is happening. Okay, so in this project what we have done, first of all we have imported the libraries, then we have imported data set and split in x and y dependent and independent variable. Then this is this is quite weird. Yeah, I'll write this. Yeah, now it's showing encoded because it's already encoded. Okay, that's why it's showing something like that. Okay, yeah, so this is data pre-processing phase. Here we deal with missing data, and then we perform label encoding to transform or string data in numerical form. Okay, then we have done splitting part and split the data set so that 80% consume for 80% of data set consume in training process and 20% consume in testing process. Okay, then we have done we have performed feature scaling so that to optimize the model training and also to optimize our result and model performance also. So that's why we perform here feature scaling. So like that we got, and then we use XGBoost model to get our result. Okay, so then we make a confusion matrix and analyze that what percent and what is the number of data set which are getting a right result, and how much we get a true positive value, how much we are getting false values, and how much we are getting true negative values. All this we got with the help of confusion matrix, and then we get this accuracy by using this metric class and this accuracy score class. Okay, and then we compare our predicted value with true value. Okay, by using this logic. Okay, and by using this x is equal to 1, x is 1 represent vertical concatenation, x is 0 represent horizontal concatenation. And then we have also learned that how we can do a single prediction. Okay, suppose the data set is given something like that, so how we can do the single prediction. Okay, this sc.transform we have used because we want to transform this, we want to scale this feature so that our model will give a good result. Okay, and then this logic is if result is equal to 0, then we simply want that print that person makes below 50k. If result is 1, then print that person makes above 50k per year. Okay, so that's what our prediction is. Hope you guys enjoy this video, and I will provide the data set and also the complete code in the description. So don't worry and keep learning and stay happy.